Welcome to today's lesson where we explore the fascinating concepts of seismic wave. Scientists rely on seismic wave to study the Earth's inner layer. What are seismic waves? Seismic waves are the energy waves that travel through the Earth after a sudden release, like an earthquake or explosion. And there are two main types of seismic wave: body waves and surface wave. First up, body waves. These travel through the entire body of the Earth, and we have two types of body waves: the primary wave or P wave, the fastest and can travel through solid, liquids, and gases, while the S wave are slower and can move only through solids. P waves move back and forth, just like how sound moves through air. While S wave, however, shake the ground side to side like a snake moving. Here's a quick summary. P waves arrive first and S wave comes next, but they are larger and are both body waves, meaning they can travel through the Earth's interior. Surface wave, on the other hand, travels along Earth's surface. These are the ones that can cause most of the destruction. There are two types of surface wave: love wave and Rayleigh wave. Love waves move the ground side to side, while the Rayleigh wave roll along the ground like waves in the ocean, shaking the ground in both vertical and horizontal direction. Love and Rayleigh waves are responsible for the shaking that we feel during an earthquake or an explosion. Because of their movement and larger amplitude, they are the ones that causes buildings to collapse. Seismographs record the arrival of different waves. First, the P wave, then the S wave, and lastly, the surface wave. The time between the P and S wave arrivals help us determine how far the quake had occurred. Ever heard of the P wave shadow zone? It's an area where there are no P waves are detected. Why? Because they bend or refract when passing through the Earth's liquid outer core. S wave behave differently. Since they can travel through liquids, they get completely blocked on the outer core, leaving a huge S wave shadow zone. This is one of the main reasons we know Earth has a liquid outer core. Now let's talk about seismic discontinuities. The Morovic discontinuity or MOHO is the boundary between the crust and mantle. It's where the seismic waves suddenly speed up, a clear sign of a material change. Let's wrap it up with this comparison. P waves are computational waves and are the fastest. S waves or shear waves, they are quite slower and travels only through solids. While love waves are horizontal wave, surface level shaking, and Rayleigh waves are characterized by rolling motion and causes most of the damage. Again, we can see the order of the waves' arrival on the seismographs. This helps scientists triangulate the epicenter. Finally, seismic wave help us to understand Earth's internal structure, such as the crust, the mantle, outer core, and inner core, as well as the key boundaries like the MOHO, Gutenberg, and Lyman discontinuity. That's a wrap on our journey through seismic wave.